Recently we did a poll asking what you would like to see on the channel, and the winner of that poll was Django-tenants. So democracy has spoken. Here we're going to look at Django-tenants and tenanted Django applications. And we're going to implement this application, obviously using Django and using a Postgres database alongside the Django-tenants package. So we have loads to cover. Let's dive in. Before we do so, if you want to support the channel and you find this content useful, check out our Ko-fi page just below the video. And don't forget to like and subscribe as well for more useful content. And if you want, you can also check out our first Udemy course, which we've just released online. We've got a link to that in the description and on the channel as well. So let's dive in and start looking at Django-tenants. Now I want to start this video by looking at the concept of tenanted applications. And if you're familiar with that, feel free to skip to the next section. We do have timestamps under the video. Now basically a tenant represents an isolated client or an organization within an application instance. And this is an important concept in software as a service or SaaS applications. And it provides a way to separate one client's data from another client's data in your database, and it prevents that mixing of data. So let's imagine you have a SaaS application. It could be a project management tool or a CRM, or it could be the latest wrapper around OpenAI. What you can do here is, instead of creating a separate instance of the Django application for each client that you have, you can instead serve multiple clients or tenants from the same code base and the same database, and of course use the same Django model classes that you are normally using in your application. But the difference is that each tenant will get its own isolated data, so they cannot see or access other tenants' data if you set it up like that. Now this is normally achieved in one of the following ways. You can have one running Django application instance and one database, but you have a separate schema within that database for each tenant that you have in your application. And that one database can store the data from multiple separate tenants. Another approach is you can have one running application, but you can actually have a separate database for each tenant. So imagine you have 40 different clients or tenants signing up to the application. Each one of them gets their own Postgres database in that case. And that gives them a greater degree of isolation of data, but obviously comes with a cost implication if you're running 40 separate databases. And the final, most expensive approach is to have a standalone Django application for each client and also a standalone database for each client. And that way the applications themselves never interact. They don't actually share the same code. So you have complete isolation, but obviously that is the most costly approach. So those are three different approaches for tenanted applications. But one common underlying theme is that tenanted apps should have data segregation and security built in, whether it's by using schemas in one database or by separating data into multiple databases for each tenant. And this is key in SaaS applications. Each customer is a tenant of your company and their data should often be isolated from data for other tenants. Now Django natively doesn't provide an easy way to build a multi-tenant application, but there are a few packages that can help. And here are the two most popular. We've got the documentation open here for Django-tenants. And this is the one that we are going to look at in this video. There's another very popular one called Django-tenant schemas, which has 1,500 stars. And both of these provide good support for building multi-tenant applications using Django and Postgres as the database. So that's a bit of an introduction to multi-tenant applications, with the key idea being that each tenant should have their own isolated set of data, but it is also possible to share data, as we'll see as well. Now if we look at the documentation for Django-tenants, when we install this package, what we have is multiple customers that can run on the same instance, the same Django application, and they can have both shared and tenant-specific data. And you also have tenant view routing as well. Now this is all driven by schemas in PostgreSQL, so the approach that Django-tenants takes is that first approach that we saw before, where we have one Django application and one database, and then in that database we have a schema for each tenant that we have signed up to our project or our application, our SaaS, whatever it may be. Now a schema in a database is similar to a directory on an operating system, and each schema can have its own set of tables, its own set of objects within that schema, and another schema can have its own set of tables as well, and they are isolated from each other. And we'll see exactly how that works very soon. And you can see here under this section here, there are typically three solutions for solving multi-tenancy. You can have the isolated approach with separate databases. We discussed that earlier on. That is more costly. Django-tenants takes approach number 2 here, the semi-isolated approach. We have a shared database, but separate schemas. And finally, you can also have applications that take a shared approach where all of the clients use essentially the same database schema, and that is the least isolated approach, so data could potentially be mixed between different clients in that case. So different approaches, and Django Tenants takes the second approach, and its rationale for that is simplicity and also performance. Now before we actually get started with working with Django Tenants, I want to look at this section on how it works, and we're going to see more about this later on. Basically, tenants are identified by their host name. So you might have a domain for your project, it could be domain.com, and each tenant has their own subdomain, so tenant1.domain.com, or you might have tenant2.domain.com, and so on. And all of the tenant information is stored in the public shared schema in the Postgres database, and whenever a request comes in, the host name is used to match that tenant in the database. And then there's some magic going on in a middleware in this package that when you find the tenant in the database, the search path in Postgres is updated to use the correct schema. And we're going to show examples of that towards the end of the video, how that actually works in Postgres. Now let's get started. I have some starter code here, and because this package works with Postgres, I have a Docker Compose file with some basic setup for a Postgres container. And we're passing in some environment variables here. So these come from the .env that we have in this project. And to actually start that database on the terminal, we can run docker compose up, and I'm going to pass the -d flag here to start that in the background. Now once that's completed, we have a running Postgres container, and what we're going to do now is we're going to set this project up. So I've already installed the packages from pyproject.toml here. We have Django and some extra packages, including 𝗖𝗵𝗽𝗁𝗲 for Postgres. And if we go to settings.py, notice at the bottom here, I'm setting a custom user model, and that is set to core.user. So if we go to the core application, we have this user model here that extends the abstract user in Django. This is a good practice, especially with tenanted applications, because if you want to customize things on the user, you need a mechanism to do that. One of the best ways to do it is to extend the abstract user. Now we're going to create a task manager application. Notice I have an app called tasks in this Django project. And if we go to models.py, we don't have any models at the moment. We are going to add them later on. But basically we want to create clients or tenants in this application that can manage their own internal projects. And each project has a set of tasks. And let's say we have a racing application and we have tenant 1 being Ferrari. We might have a domain here called ferrari.myapp.com. And when users navigate to that domain, they should only see the projects that belong to Ferrari. And similarly, you might have mclaren.myapp.com. And that again is a subdomain and a tenant within the database. And they should only see their projects at that domain. So there's a level of data isolation there, and you can build that in. We are going to build that in very soon. But the idea is that each subdomain maps to a database schema. So we will build that up in this video, but let's get started by installing Django Tenants in this project. If we go back to the documentation, we can go to this installation page. Now you can install it with pip, but I am using UV. So I'm going to copy the name of the package, and let's go to the terminal here, and let's run UV add Django Tenants, and that's going to install this into the virtual environment. Now once we've installed that, we're going to go to settings.py and look at the databases setting. Notice the engine that's being used at the moment comes from Django. It's the Postgres backend. To set up Django Tenants, we're actually going to use an engine from that package. So you can see here, Django-tenants.postgres backend. We're going to copy that engine and we can paste that into this setting. So we're switching up that database engine. The next step is to add a setting called database routers, and we're going to set that to a tenant sync router. Now you don't need to necessarily understand this, but let's just copy it and we're going to paste it into the settings.py file. And if we go back here one more time, we are going to add a middleware to the top of the middleware setting. And this is an important one. It's the tenant main middleware, and it has to be at the top of the middleware setting. So let's go to middleware, and I think we need to scroll up here and we can paste that at the top. This is the middleware that's going to handle looking at the incoming request, finding the subdomain or the tenant from that request, and then setting the Postgres search path accordingly. Now, once we've added these settings, what we can do is we can actually set up a couple of models. The tenant model and the domain model, these are important concepts in the Django Tenants package. So your tenant model represents the different tenants that are in the application, and that might commonly be called client or customer or something like that. And you also have the domain model. That is going to track the subdomains that you have and map them to a tenant. And we'll see how to use these as we progress through the video. I'm just going to copy this for now, and let's go back to VS Code, and we're going to add that to the core application inside models.py. So let me paste that in at the top here, and we can remove the duplicate import here. So what we've done here is define the client model, and that inherits from the tenant mixin. This is known as the tenant model, and we will set a setting in a second for this. And you can add any data you want to your client or your tenant model. In this case, I'm going to get rid of on trial and paid until. We're going to have a super simple client model that has a name and also the date that this was created. Now notice this field here, it's called auto create schema and it's set to true. What this means is that the schema will be automatically created and synced when this is saved to the database. So imagine we're adding the Ferrari schema or the Ferrari tenant. What's going to happen when we save that to the database is that it's automatically going to create the Ferrari schema in that database. And the domain model is going to track the domains or the subdomains that we have that are associated to the tenants. So for our Ferrari application, we might have something like ferrari.localhost. We'll see that very soon. That's the domain, and we want to tie that with a foreign key to the client model. And if we look at this domain mixin that we have here, we can see the fields that are on this. For example, the domain itself is a car field, but the tenant is a foreign key that's on this model that ties that domain to a tenant. And that links to settings.tenant model. So the next step in this setup is to actually create this setting here and also create the domain model setting. So let's go to models.py and we can save this. And once we've saved that, we can go to settings.py and we're going to create a couple of extra settings here. Let's refer to the Django-tenants documentation. And if we scroll down here, what we can see is we have the tenant model and the tenant domain model settings. We need to set these to the actual models that we just created in the core application. So let me just copy these and we can paste them into settings.py. And that was inside a core application. So it was core.client and also core.domain here. That is referring to these client and domain models that we created. We need to tell Django tenants where our client and domain models are, and we can do so, and we have to do so via these settings. Now we're going to see very soon how to actually interact with these two models and what they actually mean in the database. Now at this stage, we're going to run the make migrations command. So it's going to be uv run manage.py make migrations, and that's going to create the migration files for our new models. Now we're getting an error at the bottom. The settings object has no attribute shared apps, and that's because we've missed a key setting here. And that is the idea of tenant and shared applications. This is another intrinsic feature to Django tenants that you need to understand. And I know there's a lot of setup here, but it is a one-time thing. Once we've got this set up, it's going to work out of the box going forward. So you just need to configure this. Now the idea is that you have your installed app setting as normal, but that is a mixture of shared applications and also tenant applications. Now the models in shared applications are going to be stored in Postgres' public schema, which is the shared schema in the database, whereas tenant application models are going to be created in the tenant schemas only. They're not going to be shared in the public schema, but they're going to live in their own schemas for the different tenants that we have in the project. So just to see what this means, we need to set this up and then we can run that make migrations command. So let's go to the top here. And instead of installed apps, what we're going to do is create a setting here called shared apps. And it's important to note here that the core application must reside in this. And that's because wherever you have your tenant model and your domain model, that has to be in the public schema so that Django can look that up when a request comes in and match the request to the correct client and domain. Now, one other thing we need to do in shared apps, and I'm going to do this at the top here, is add Django tenants itself. So that has to be part of your shared apps. And if we go to the settings here, you can see this here at the top. It's mandatory to include that. Now for the tenant applications, we mentioned earlier that we're going to create a tasks application. And the project and task models that we're going to create in this application should be specific to each individual tenant. So the tasks application here is going to be a tenant-specific app. So what we're going to do is create another setting called tenant apps. And once we've done that, we can set that to a single item in this list. And that's going to be the tasks application that we can see here. And the final thing to do is create our installed apps setting, and we can copy this code here. So installed apps is a combination of the shared apps and tenant apps. So I'm just going to copy this statement here and we can paste it in below. So that combines them, and of course Django needs the installed apps setting. That is just a combination of both of these lists. Now I think that might be the final part of this setup. So we can go to the terminal now and let's try running the make migrations command again. And you can see the migrations have been created with these two new models that we have, the tenant model and the domain model. Let's clear this out. And now we're going to run a special management command that's added by Django tenants. Let's go to the documentation. And if we go to the using section here and go to management commands, you can see there are a number that are built in here. And the one we're going to use is migrate schemas. And that basically overrides the migrate command and makes it compatible with Django tenants. And it also respects the shared apps and tenant apps settings. So what we're going to do is run this command, and let's go to the terminal here. It's going to be uv run manage.py, and this command is migrate schemas. Now let's say we only wanted to create the shared tables at this stage. We can pass the -- shared flag to this. Let's try that out and see if this works. And you can see it's running the migrations. This looks slightly different than the native migrate command, but it has run that command, and now we're going to look at the database. So we're now on the database, and as you can see, this is called My Amazing SaaS Database, and we have the public schema as you can see here. Now I want to emphasize the public schema is the default in Postgres, and with Django tenants, this is the shared schema. This can be accessed by all tenants, so you can think of the data in here as being shared, and importantly, we have the client and domain tables inside the public schema. So if we look at the client table here, we have no data at the moment, but we have these columns that you can see here. We have, of course, the ID, the primary key, but importantly, a client is associated with a schema name. We're going to see examples of that in a second, and clients also have the name and created on field, and those were the fields that we actually manually added to the client model. You can see them here. And this is a normal Django model in some ways. You can add as many fields to your client as you want. And we also have the domain model as well. And if we go to that table, you can see we have the domain field, which is a varchar that stores the domain for the tenant, and whether or not that's a primary domain for that tenant, and importantly, a foreign key from the domain to the parent tenant model. Now I know this is a long-winded setup, but I do think it's important to understand how this works at the database level. We're now going to look at populating these two tables with some clients. So let's go back to VS Code and clear the terminal here. And what we're going to do is we're going to create a shell session here. So Python, or rather uv run manage.py shell is the command I'm looking for. So when we run that, we get the Django shell opened, and we have our models automatically imported. And we have this client model here that we're going to use to create a tenant in the database. Now there's an important concept from Django tenants that we need to look at. So let's go back to the installation page, and we're nearly done with this setup, I promise. And we can go down to this section on configuring the tenant and shared applications. We already did this with shared apps and tenant apps. But if we scroll down after we configure the tenant model and the domain model, what we can do at the bottom, or what we can read here, is that what we need to create is a tenant whose schema is public, and that public tenant's address is going to be the domain URL. Now we can see more information on this by clicking through to the link here. So when we create a tenant, it's like creating any other model in Django, but we have to create this public tenant to make our main website available. So this is a configuration quirk of Django tenants, but what we're going to do inside our shell session is create a client model and then save that to the database. So let's go to VS Code here and create a tenant. So we are instantiating the client model. And remember from looking at the database that a client needs a schema name. So we're going to need to set that here. And if we look at the documentation, this is going to be set to public. And that is because this is the public tenant essentially in the application. So let's paste that in here, and we can give this a name, and it can be anything we want. I'm just going to call this root. And then once we've created that tenant with the fields, we can then call the save method to actually save that to the database. And then after we create the tenant, we need to add one or more domains for that tenant. So this is simple. We instantiate a domain, we set the domain here, and this should be the actual root domain of your website. And then we can set the tenant foreign key and save that to the database. Let's do that just now. We can instantiate a domain, and for us, it's going to be localhost. So we're going to set the domain field to localhost, and then we can set the tenant here. That's going to be the foreign key to the tenant that we created above here on these lines here. And finally, let's save that to the database. Now, after we've done that, we can go back to the database and we can refresh and see the data that we've entered. So we have the public schema represented in this client table. And if we go to the domain table and refresh this data, we have our root domain, in this case localhost, and that is linked to tenant number 1. Now we can go back to the documentation here, And once we've created that, you can then start creating real tenants in your application. And of course, a real tenant, a real client is going to sign up somehow. And it's at that point you would create these tenants in the database. So the workflow there would be that a client would sign up. You would save that into the database programmatically using these client and domain models that you can see here. Now, there are other ways to create tenants. There's actually a management command for this. So if we go to the management command section here, there's a create tenant management command provided by this package. Now I'm going to show how we can run that to create our first Formula 1 tenant. Let's exit out of the shell here. And we're going to run the manage.py create tenant management command. Now this is going to give you some options to fill this in and create the tenant. So let's say the schema name here is going to be Ferrari. And remember, that schema is going to be something that exists in the database. It's not going to be the public schema. This is going to be tenant specific. So this is the name we're giving to that schema. And the client themselves, of course, Ferrari, have signed up and will be using this application. And notice that that applied some migrations there. And at the bottom, we now are prompted to enter the domain. Now the domain I'm going to use here is ferrari.localhost. That's going to be the domain, and we're going to set that as the primary domain in this case, and we can clear the terminal. Now let's look again at the database. If we go to the domain table, notice we have ferrari.localhost represented, and that is linked to tenant number 2. And if we go to the client table here, you can see tenant number 2, this row represented here for Ferrari. So our new application, our SaaS, is up and running. We have Ferrari as a client. Another thing we can do is add tenants and domains inside the Django admin. Now, in order to do that, we can go back to VS Code, and I'm going to bring back the sidebar here and go to admin.py, and we're going to register the tenant model and the domain model in admin.py. And there's a useful snippet in the Django-tenants documentation, so I'm going to copy this here, and we can paste it into admin.py and go over this. So we import this tenant admin mix-in, and as we can see here, this disables the save and delete buttons when we're not in the current or public schema, and that prevents some exceptions. And from core.models, we're going to import client. So let me fix this here. We're importing the client or the tenant model, and then we register that here. And from the list display, we're going to remove paid until because we didn't actually use that field. So we create an admin class here, very simple, and we're also using the tenant admin mixin. And I'm also going to import the domain model here, and we can have a very similar class below here. So we're going to register the domain admin. And once we've done that, we're going to create a super user with uv run manage.py, and it's the create super user command. And we'll give this user a name of 𝗵𝗽𝘁𝗲𝗄𝗏 and a password of test, very standard password here. And then we can run the Django server, and we're going to log into the admin UI. And this is going to give us another way to create a domain and a tenant. And we're now in the Django admin, and you can see under the core application, we have the client and domain models. So let's start with the client model here. We have Ferrari, let's say McLaren are now interested. So we're going to give McLaren a schema called McLaren. That makes sense. And the actual name of the team is McLaren. And I think this should have a capital L. And we can then save our new client McLaren to the database. And now we can go to the domains section, and we can add a domain for our new tenant. So this is going to be mclaren.localhost. And we need to link that to our tenant. Of course, that's going to be McLaren. And then we can save that. So we can now add tenants and domains to this application. We can do it programmatically, or we can do it with the Django UI or with a management command. Different ways to do this with Django tenants. What we can now do is actually go to our application. So if we go to localhost 8000, we get this Django installation page, and that works fine. But notice this here, we can actually go to ferrari.localhost 8000, and we still get the same page. And that's going to be true also for McLaren at the top here. But if we actually put something that's not a registered tenant here, we get the 404 not found. So we have a specific tenant page for each of the tenants that we have in the application. And if we enter something that doesn't exist, we get this error here, no tenant for the given hostname. And you can see if we go to williams.localhost, we get a 404 not found. So this does not work because at the moment Williams have not signed up for this application. They don't have a schema, and therefore we get the 404 not found. So we're now going to move on and look at adding tenant-specific data to this database and accessing it in the application. Now before we do that, let's go back to the database here, and I want to highlight that we have some new schemas. We have the Ferrari schema here, and we also have a McLaren schema. So what happened there is when we actually created the client model, when we saved that with the Django admin and with the management command, What happened was, because of this setting of auto create schema set to true, when that client model was saved to the database in the client table, the schema for that client was automatically created, and that's why we now see these in the database. So this is one database, but it has multiple segregated schemas, which is the idea behind tenanted applications here, using one database but multiple schemas for separation. Let's now move on and look at creating data. So we're going to look at the tasks application. Remember from settings.py, this was the only tenant app that we have at the moment, which means that any models we create here are not going to go into the public schema, which is the shared schema. Instead of that, they're going to be created in the schema or tenant-specific tables. So Ferrari will get their own version of any models, and McLaren will get their own version of any models we add to the tasks application. Let's see that in action just now. We're going to go back to models.py. Now I'm going to paste in some normal models here and we can have a look at these. I don't really care about what's in these models. We just want to show the concept here. We're creating two models. One is a project, and the project is going to be specific to Ferrari or specific to McLaren. It's tenant-specific data. And within the models.py, we also have a task model. Tasks are linked to a parent project. That means you could create a project, for example, how to win the Monaco Grand Prix, and that could be comprised of multiple tasks. But the important thing here is that these are going to be tenant-specific models that exist in the schemas and not in the public schema in Postgres. And there's nothing else about these models that differ from normal Django models. The only difference is they belong to an application that is part of the tenant apps list in settings.py. Now let's stop the server at the bottom here. And of course, we've added new models, so we're going to run the make migrations command, and that's going to create the migration file. And then once we've done that, we can run that special management command from Django-tenants, and that was migrate_schemas. Now we can get rid of this shared flag. We're not going to use that here. But let's run this command and we're going to see what happens. And notice that it's applying migrations to the Ferrari schema, but also to the McLaren schema. Now normally when you run migrate in a normal Django application, it runs the migration against the public schema and that's it, no other schemas. But here we have something different. We have all of the schemas that are registered, all of the tenants that are registered, that is being applied to all of these schemas. Now let's look at this from the database level. So if we go to the Ferrari schema that we have here, we now have two new tables, one for the project and one for the tasks. And that is going to be the same in McLaren. This particular schema also has the same tables, but they are logically separated into different schemas. And that means that we can add projects to Ferrari's own table here, and that is not going to affect the data that's in the project table in the McLaren schema. So we have a degree of separation here. And if we look at the public schema here, which is the shared schema, there is no task and project table in this because this is not shared data, it's not public data. This is reserved for shared applications, but the tenant tables like project and task, they are added to tenant-specific schemas. So I hope that makes sense, and I really want to drill that in here. We have a public schema, which is the normal PostgreSQL schema that is shared across all of the different tenants. There is nothing isolated about any of those tables and the data within them. But for all of the tenants that we have in the project, they each have their own schema with isolation, and that is determined by that setting that we saw inside settings.py. So let me minimize that. It's the tenant applications. Any models here are only created inside the schemas associated with all of your tenants. That gives them separation, and I think I've said enough about this. So let's now move on. Now let's move on and look at creating a list page for the projects in this application. So in the tasks application that we have here, we're going to create a view that's going to list out all of the projects associated with a given tenant. And that's going to happen automatically, as we'll see in a second. So at the top here, we're going to bring in an import, and we're going to import the project model here, and we can create a view called project list in Django, and that takes the request object as a parameter. And what I want to do to start with is print something here. And in the request object, sometimes we have access to all of these useful properties like request.user, request.session, and so on. The Django tenants package adds another useful property, and that's request.tenant. And this is actually added by that tenant middleware class that we added to the middleware setting at the start of the video. So request.tenant gives you access to the current tenant that's sending this request. So again, middleware in Django often augment the request object with additional properties that are useful. This is an example of that. And then what we can do is pull the projects from the database. So that's going to be project.objects.all. And because we want to get maybe the associated tasks, we can also prefetch the related tasks associated with each project. And then it's going to be pretty simple. We're going to create a context dictionary with a key called projects, and we can map that to what we pulled out of the database. And finally, I'm going to render a template here with that context. Now let me just paste this in for brevity. This is going to be project list.html. That is a template we're going to need to create in a second. But here we have a simple project list view that is going to fetch all of the projects from the database for a given tenant, as we'll see in a second. Let's now go to urls.py, and to the URL patterns, we're going to add a URL that's going to map to that view. So let's import the views at the top here, and we're going to paste in a URL path, and that's going to map to the project list view that we just created. Now, once we've done that, we can go to the templates directory, and inside this tasks subdirectory, we can create project list.html, and that's going to extend that base template that we have here in tasks/base.html. Now, if we look at base.html, we're going to have a content block here that we're going to extend. So let's paste that in here. And we're going to keep the HTML here super simple. So let's have a root div with some basic styles here. And then we're going to have a header1 tag. And what I want to render here is request.tenant.name. So we'll see what that is in a second. And then we're going to list their projects. So let's add that text here and close off the header1 tag. Request.tenant is going to refer to the tenant model setting. And remember the .name property, what is that referring to? If we go to the tenant model, which is the client model that we have here, we had a custom field called name, and that is going to map to, for example, Ferrari or McLaren and so on. So our clients have a name, and request.tenant is added by that middleware, as we'll see in a second, and that gives us access to the currently active tenant based on the URL. We'll see all of that very soon. We can then check if we have any projects. So we'll have an if statement here in the Django template. And don't forget to end that if statement below. And I'm just going to paste this in here because all of this is standard Django stuff. We're going to check the number of total projects that have been found using the length template filter here. And then we're going to iterate over each project in a template for loop and render out the project name. And we can also define an else block here that's going to be super simple. So if we don't have any projects, we can just display this message, no projects found. Let's now save this. And at the bottom, we can run the server with manage.py run server. And we're going to go to this page. And we're still on this Williams page here. I'm going to remove that. And let's go to ferrari.localhost.8000. And we're now getting this error, template does not exist. And that's because I've named this slightly incorrectly. It's not an underscore here. It should be a dash here. So let's replace that. Hopefully now we are all good and we can refresh this page and we get Ferrari's projects. Now notice that Ferrari is the currently active tenant. We get that from request.tenant in the template. And if we go to the terminal here, notice Ferrari has been printed out on the terminal. And if we go to views.py, this corresponds to line 6, where we print request.tenant. So I'm going to remove that now. This just demonstrates that the middleware adds that very useful request.tenant property to the request. And if we go to the browser here and change this to mclaren.localhost8000, we now get the McLaren tenant and their projects should be listed here now. Now, of course, at the moment, for both of these tenants, we have no projects found. We're going to look at adding some projects now, and I'm going to do that using the Django admin. So let's go to the tasks application and go to admin.py, and I'm just going to paste this code in here to get things moving along. And then once we've done that, we can go to the admin UI. So I'm now on the Django admin, and notice the URL, it's mclaren.localhost8000/admin. So I'm on the McLaren tenant admin at the moment. And notice here we have a slightly different UI. And basically shared tables or shared models have the normal color, but any tenant-specific models have this green color here. So the app itself has the green color and the models are listed underneath that. So if we go to projects here, we can add a project, and this should only be added to McLaren's data. So let's give this a name of Monaco Grand Prix Race Strategy, and we can save that. And we'll create a second project with the name Tire Management Post-Summer Break. Let's save that. And actually, let's go back to projects. We now have 2 projects, hopefully only associated with McLaren. What we can now do is switch to the Ferrari interface. And when we do that, we're prompted to log in again. So I've now logged into the Ferrari admin UI. And if we go to projects, notice interestingly here, we don't have any projects. There are none for Ferrari. And that's because this is actually looking at a different schema in the database, the one associated with the Ferrari tenant. So now we can add projects specific to that tenant. And let's keep that simple. Change drivers, we'll add a single project and that'll be it. And we can now go back to the actual application itself. So to do that, we can go to ferrari.localhost 8000 and notice now we have a single project listed here and it's the change drivers project. And if we change this to McLaren at the top, we now have McLaren's individual projects, 2 of them in this case, and they are isolated or separated from the ones that are tied to the McLaren or the Ferrari tenant, sorry. So now we have tenant-specific data, we have tenant-specific domains that are accessed, and what we can show is that in the database itself, if we go to the project table associated with Ferrari, let's go to this table and view the data, we have that individual project and it's in the Ferrari schema here. If we close that and go to the projects for McLaren, notice that we get the 2 rows that we added for McLaren. So now we have this separation of data, and when we are on a particular domain associated with our tenant in this SaaS application, we only get the data for that tenant based on their schema. Now at the end of this video, we're going to look in a bit of detail about how this happens technically, and we're going to look at Postgres schema paths and also the flow of data as a request comes into the Django app when you have Django tenants installed. Let's now finish by showing how to actually add some data. So to do so, we're going to move fast here and we're going to create a form in Django. So I'm going to paste a form in here called project form, and it's got some fields here for the project. We're going to add a name, a description, and a Boolean flag is completed. So that's a standard Django form. And if we go to views.py, let's create a new view in this application. Now there's a couple of things I want to import at the top. So let's import the form class that we just created. And also from the shortcuts module, as well as render, we're going to import redirect, because when we submit the form to create new data, we want to redirect the user to a new page. And finally, we can actually create the view itself, and we can do that underneath the list view that we already have. This one's going to be called project create. So on a post request, what we're going to do is create the project form. If it's valid, we're going to save that to the database, which is going to create a project in the database because this is a model form that's tied to the project model. And then once that's saved to the database, we will redirect the user to the project list page. And then for a GET request, we simply create the form, add it to the context, and we are going to display this template here. And that's going to be a project create template. Now, once we've created the view, we're going to create the URL here. So let me paste this down to the line below, and we're going to link this up to project create. And let's give this a path of /create here. And the final thing to do is give it a name. That's going to be project create as well. So we're moving fast here. Hopefully you understand these concepts. If you're looking at Django tenant, you should probably understand core Django functionality. And now let's create the template here. So in the tasks directory, we can create project-create.html. Now this is going to be a super simple template as well. We're going to extend the base template and define this content block. And inside this, we have a simple form. And of course, it's going to be sending a post request to the server. So we include the CSRF token and we just render the form as is. This is going to look terrible, but we're going to do this anyway. And then finally, we have the submit button as part of that form. So we can save that. And the last thing I want to do is go back to the list page. And at the top here, just underneath the project section, I'm going to paste in a link that's going to take the user to a page that allows them to actually create the project. And we use Django's URL template tag to do so. So let's test this out by going back to the application. We can refresh the list page and we now have a link on the McLaren tenant here to create a new project. So here we have this stunning looking form, as I mentioned. I'm going to fill this in just now. And we have a project here to win the championship. Simple project, it seems. Let's submit that to the server and notice that it now appears under the McLaren projects in this tenant. But again, if we go to ferrari.localhost, that is not part of this schema. So we have again the ability to create data in the database and it is associated with the correct tenant in this case. And if we look at the database for McLaren, let's refresh this data and we have our new field, our new row rather, coming through into this database. So again, separation of data, and that's the key idea behind tenanted applications, whether it's in Django or any other tool. Now we can do exactly the same just for demonstration purposes for Ferrari. Let's create a project here. So we have a 𝗖𝗵𝗽𝗀𝗀𝗲𝗄 project. Let's submit that and you can see it appears here under Ferrari's projects. And again, if we go back to the table for Ferrari's projects, let's refresh this and we can see it appearing here. Segregated data, and that data is fetched when we go to the list page, and when we create new items in the database, it automatically uses the correct schema. Now I do want to note something here. At the moment we're not using any authentication in this application. So we can access Ferrari's data here, the Ferrari tenant. If we go to McLaren, we can also access that tenant's data. In a real tenanted application, you obviously want a user to kind of belong to only one tenant perhaps, or maybe a couple of tenants, but you don't want them to be able to just switch to another tenant and get that data. So there are mechanisms to prevent that. We can look at that in a follow-up video if you want, where let's say we register a user for McLaren, it could be Lando Norris. That user is tied to the McLaren tenant, and if they try and access any data on another tenant that we have in our SaaS application, they should not be able to do so because we have permissions built in to prevent that. So we can look at that in a future video if you want. This video is an introduction to Django tenants and the concepts and mechanism by which this works. Now at the end of this video, I just want to look at how this all works under the hood. How does Django tenant achieve this using the schemas and so on? So I want to visit the flow of data as a request comes into Django when you have Django tenants installed. So remember we installed this middleware class earlier on. Let me find that just now. So we have the tenant main middleware from Django tenants. And that middleware is actually adjusting the Postgres search path to perform the correct lookup. So the flow is as follows. A request is going to come in and that request will have a domain, for example, ferrari.localhost. And because we've added this middleware here, it's going to hit the tenant middleware before it routes to our URLs and views. And this middleware is going to inspect the host header of the request to identify the domain. So again, that could be ferrari.localhost. It's going to inspect that and pull it out. And then it's going to look up the public schema and query the domain model. So let's say it finds ferrari.localhost in the host header of the request. It can then look up the domain model here. And it can find an associated domain by looking up this column here, and that can then give it access to the tenant ID. In this case, it would be tenant number 2. And by the way, we do have another domain here. Let me refresh this data. So we have tenant number 2, and it's pulled that out by looking at the host header and then doing a lookup to this domain table, which links the domain to the tenant. So we can then go to the tenant table, which in this case is the client table. And again, I'm refreshing that data here and we can find the tenant with the ID of 2. And this is the tenant identification section. It's going to find that tenant there, and that is ultimately what gets added to the request object. Remember, we looked at request.tenant earlier on. It's going to be the model represented by this row here. So the middleware pulls this data out and it creates that tenant model, and that tenant is added to the request. And after that, the magic step happens. That's the schema adjustment step. And notice the schema name is set to Ferrari here. And it's basically going to use that field there. And it's going to change the Postgres search path to use the schema of Ferrari because that is what's set in this column. So the middleware class calls a function that switches the database connection's search path to this schema Ferrari. And then from there, the request continues to Django views, and any database queries that happen after that will automatically use this tenant here of Ferrari. We'll use that schema in the database. And that ensures the data isolation that occurs in a tenanted application. It does so by switching the search path and using the correct one based on the tenant it's identified in the request. Now, the final thing I want to do here is just look at how this schema is adjusted. So in order to do that, I'm going to create a new tab here where we're going to execute some SQL. So let's create a new tab here. And let's say we want to look something up in this database. We're going to look up the tasks project table and select all of the data from that table. So let's issue a select statement here, select all from tasks_project. And this is going to fail because this relation does not exist. Now the default search path in Postgres is to use the public schema. But the problem here is that the project table does not exist in the shared public schema. That was part of a tenant application, the tasks application in Django, and therefore it's only in the schemas associated with each tenant in our application, so Ferrari and McLaren. Now what we could do in the query is specify the schema here. For example, select all from Ferrari.tasksProject, and that will give us back the projects associated with Ferrari. So you can put the schema in front of this from part of the select statement. And we can also update that as well to use McLaren to get their projects. Now there is another approach we can take here, and that's to set the search path in PostgreSQL. So the search path, that is the approach taken by the Django tenants package. And all we need to do before we issue the select statement is set the search path in this case. So set search path, if I can spell that correctly, and we can set it to a particular string here. So if we want to only search Ferrari, we can set it to Ferrari there. And then when we execute this second statement, the select statement, even though we are not selecting a schema in that statement, the tasks project table exists in the Ferrari schema. And because we've set the search path to that, it's going to be able to find these projects. And similarly for McLaren, we get the same result, but the McLaren specific tenant data. Now the Django-tenants middleware is going to set this search path accordingly based on the domain, but what happens if we do want to get one of the public data tables? For example, if we want to get the core user table, we can issue the select statement, but because the core user table is not in the tenant schema, it's in the public shared schema, it's not going to find that data. So another thing you can do here is you can set the search path to a comma separated list. So it's going to search them in order. So if it doesn't find it in McLaren, we can set the public schema as the second part of the search path. And now we get the result from the shared schema. So you can have as many schemas as you want as part of the Postgres search path. And the way this is going to work is it's going to search the first one of these, the first schema, McLaren in this case. If it finds the result, in this case the core user table, it's going to return that data. Otherwise it will move on to the next schema. In this case that's the public schema. And it will search that schema until it finds or does not find the associated tables. And just to demonstrate this is working with tasks_project, we can issue that search there. And because that finds it in the McLaren schema, it no longer has to go and search the public schema. So that is how you can set these search paths in Postgres. And Django-tenants sets this search path in the database when the request comes in, and it's going to use that search path for all subsequent database calls in that request until the response is sent, and that is reset by the database connection. So that has been an introduction to Django-tenants. What we've done in this video is we've learned how to set up Django-tenants, and we've learned how to specify shared applications where the data is shared in the public Postgres schema, as well as tenant applications. And tenant apps, the models within those are created, the database tables rather, are created in the tenant schemas in the database. And there's going to be one schema per tenant that you have in your project. And we saw how this works by adding a tenant main middleware here, and that is going to change the Postgres search path based on the incoming request by looking at the URL. So if we go to the browser, when we are on the subdomain for the Ferrari tenant, we only get their projects from the database, and that's because it's looking up the correct schema in the database, and we can switch that to another tenant in order to get their projects. And we also saw the concept of having a tenant model. In this case, it's called client, and you can add any number of fields to that client model as you normally would in a Django model. But the difference is it's using this tenant mixin, and all tenant models must inherit from that tenant mixin class. And we also have the domain model here, and that will store details on the domain and link the domain to the correct tenant. And we use these two models in settings.py to set the tenant model setting and also the tenant domain model setting. That's a key step with Django-tenants. And we also saw in this video the migrate schemas command, which you can use to create the database tables in the correct schemas. So when you have a shared application like tasks, if we go to the models for the tasks application, so we can click here, we get taken to the project and task models here in that application. Because they are tenant apps and these models live in the tenanted application, what happens is the tables get created inside the tenant schemas, and that's why we see them here in the Ferrari schema and also the McLaren schema. And finally, if we look at views.py and look at the different views that we had in the application, notice that the ORM queries here do not specify any kind of schema switching themselves. That's all handled by the middleware. We can just query the database as normal, for example, by selecting project.objects.all. And Django-tenants will handle fetching the relevant objects from the correct schema in the database. So that is transparent once you add this middleware. So that's all for this video. There are some extensions we could add if you're interested. Let me know in the comments. For example, we could look at user management with Django-tenants. At the moment, there's no authentication in this application. A user can just go to one of the subdomains for a tenant, and they can then see that data and then switch over to another subdomain and see that data. So there isn't really isolation there. You need to add extra functionality if you want to achieve that. What we've done in this video is shown how this works on a technical level at the database level and in the application, but there are extra steps you would need if you want to have per tenant users, for example. We can dive into that if you're interested in a future video. And we could also look at how to work with Django-tenants and different schemas in the database when you're defining things like celery tasks. Django Tenants does provide utilities that help make this work with management commands and celery tasks and so on, because remember, the middleware that looks at the incoming request object, that's what determines what the correct schema is. But in a management command or a celery task, you might not have an incoming request object. That could be something that you need to work with in the background, and therefore you need another way of working with different tenants and schemas. So there are tools for that. Let me know if you're interested in that topic as well. Otherwise, thank you for watching. This has been a whirlwind tour and an introduction of Django tenants and the idea of tenanted applications in general. And we also saw a little bit about how PostgreSQL actually finds tables in different schemas. So we've looked at all of that. And any extensions you'd like to see, let me know in the comments. And finally, if you want to support the channel, check out our Ko-fi page. Thank you very much to everyone that's contributed to that. And if you are getting any value out of this content, don't forget to like and subscribe as well. Thanks again for watching, guys, and we'll see you in the next video.